Hello friends, I am Chandan. This is my handwritten notes useful for GATE, ESC, ISRO, DRDO, BARC and other competitive exam. You can download it from the description link. Today's topic is free expansion. This video is only useful for mechanical engineering student. You can see that video. Now here, now our topic is free expansion or Joule expansion or unrestrained expansion. Okay, so free expansion is also known as Joule expansion or unrestrained expansion. So let's try to understand what is free expansion. Suppose there is a cylinder. Inside this cylinder there is a gas is given, and this cylinder is connected to another cylinder. There is a vacuum or evacuated cylinder. Okay, these two cylinders is connected with the valve. Here there is a valve is given, and if you open this valve, then the gas is going to this side to right side, that is vacuum place. So here expansion of the gas against vacuum is known as basically free expansion. So here gas is when you open the valve, the gas is going from left side to right side, right side, because there is a vacuum. So that is why the gas is going from this side to that side. So that is why this process is known as free expansion process. There is another example. Suppose there is a cylinder. Here there is a cylinder. Inside this cylinder there is a pressurized gas is there, and outside this cylinder there is evacuated, the outside that is evacuated. Now suppose there is a leakage. Suppose there is a leakage is there. So basically the gas is coming from this cylinder to the vacuum. So expansion of the gas against vacuum is known as free expansion. So this is also the example of free expansion. Now if you see another example, suppose there is a gas, there is a whole cylinder here, and there is a one partition is there, and in the left side the gas which have some pressure, and the right side that is vacuum or evacuated. That means there is no air or there is no gas and there is no pressure. Okay, so that is why when the partition is removed, then the gas is going from left side to right side. This is the also example of free expansion. So what is basically the free expansion? Here the definition is also given, that is expansion of the gas against vacuum is known as free expansion. So this is very important. Expansion of the gas against vacuum is known as free expansion. In this process, this is very fast process. That is why that is less time required, and due to this less time the heat is transferred, the amount of heat transfer that is equal to 0. So from here you can say that it is an insulated process, or in question that is insulated. So if it is insulated, that means it is a free expansion process. Now gas is transfer. So gas is transfer to the vacuum. So that is why here just understand this, very important, because so here gas is going from pressurized to vacuum place. So that is why there is no work, because there is no resistance force. Okay, so that is why there is no work. So in free expansion there is no work. That means in free expansion W is equal to 0. Now we know the formula W equal to PdV. So this formula in free expansion, this formula is not valid for free expansion. Remember this data, that is W is equal to PdV. This formula is not valid for free expansion. So here volume increases, but this is the example of irreversible process, but in a closed system. Okay, so volume increases, so here volume is increases. So that is why this formula is not applicable. Okay, now if you apply the first law of thermodynamics formula, del Q, that is equal to dE plus del W. So the W is equal to 0, you see that, and del Q amount of heat transfer, that is equal to 0. From here you can get that is dE, that is equal to 0. Okay, from here you can get that is initial energy, that is equal to final energy. And energy, basically energy is equal to, we know that energy means internal energy plus kinetic energy plus potential energy. You know the energy, that is energy is equal to internal energy plus kinetic energy and potential energy. And if the kinetic energy and potential energy are neglected, from here you can say that initial internal energy, that is equal to final internal energy only if the kinetic energy and potential energy are neglected. So from here you can get this formula, that is internal energy is a function of Cv into Ty, is a function of temperature. So here Cv into T1, and so T initial, or you can say the Ti, and Uf, that is equal to Cv into Tf. So here CB cancel out, and you can get the initial temperature, that is to final temperature. This is only valid for ideal gas. Okay, so from here you can find that is P1 V1, that is equal to P2 V2, and this formula is valid only for ideal gas free expansion process, and change in kinetic energy and potential energy are neglected. When this three assumption is there, then you can find this formula, that is P1 V1, that is to P2 V2. Okay, so what let's try to conclude this free expansion process. In case of free expansion, heat transfer is zero because it is a very fast or insulation process, so that is why the heat transfer is zero. Now in work done is zero because gas expansion in the vacuum, so there is no resistance, so there is without resistance, that is why the work done, that is equal to zero. Now now uh, the last conclusion is that the formula like pdv is invalid because it is irreversible process. So that is why the formula like pdv, it is invalid because it is an irreversible process. Okay, so thank you. This is my handwritten notes. You can download it from the description link. Like, share and subscribe my YouTube channel. Thank you.